Thank you, Joe, and thank you everybody for joining. Like Joe said earlier, I think we have a few people here who may have joined before, so maybe you're just getting a refresher, or maybe you're bringing some good questions later. But we will be going over exactly what Signal Scout is, giving a little demo of how it works, and at the end, definitely opening up to questions. And along the way, if I am unclear or if there is anything that I need to double back on, please let me know. So we'll go ahead and get started with a brief PowerPoint and then get into the demo. So Signal Scout, what is Signal Scout? Our little quick blurb on it is Signal Scout is troubleshooting software that combines program logic from signal controllers with live status or logs. So Signal Scout helps the user find the root cause of troubles more quickly and easily. And Signal Scout can also be used as a training tool to create specific scenarios. So, you know, in the older days and sometimes in the current days of signaling, we used to only need a couple of things to do troubleshooting, and that was often just a multimeter, a set of plans, and with those two things, we could run around a signal house that was full of relays, figure out, you know, where we were having our power get to and where it was stopping, and that was often enough to troubleshoot exactly what was going on. Well, we've now moved on from houses full of relays, and now we've pushed all that information that was on the prints in relay form into our application programs, into silicon-based logic devices. So now, you know, where we used to look at our plan sets, all of that's now in our program application. And unfortunately, we can't get all the information we used to get just from a multimeter and being able to look at shelves of relays. Instead, we have to go in and get access to this information through our computers and through these interfaces to these devices. So because that's not super simple all the time, that's where Signal Scout comes in. And I like to use the analogy that Signal Scout is like the Google Maps of signal troubleshooting. So before Google Maps was around, in order to navigate, you know, from one place to another, you might have multiple things that you utilized. You would use a physical map that you could get out, you know, plot your course on, figure out how are you going to get from point A to point B. You might listen to a traffic report to figure out if your chosen route was going to, you know, encounter some traffic and whether you should reroute. And you might bring along a co-navigator, somebody who'd keep track of where you are on that route, tell you what, you know, when you need to turn right, when you need to keep going straight, that sort of thing. And that worked, but it wasn't, you know, exactly the easiest thing in the world to do. And then with our smartphones and GPS and computers becoming better, you know, Google Maps and the like came along, where now, instead of having all those separate things that we have to get various inputs from, we now just put in our destination into our smartphone, and our phone is going to tell us exactly how to get from point A to point B. It's going to take into account the route that's quickest to get somewhere. It's going to tell us exactly where we are on that route. It's going to let us know, you know, when to turn, what's upcoming, that sort of thing. So in a similar way, Signal Scout does that for signal troubleshooting. Essentially, we have information in different places. We have, you know, our map could be referred to or could be equivocated to our program logic. So, you know, that is kind of the piece of information that's going to take us from one point to the next. Then we have some information about what our current state of bits and statuses is. That could be either a log that you're downloading from a piece of equipment, or it could be live status from a piece of equipment, real-time information. And we also have other information that we're bringing in, like nomenclature, possibly IO information. You know, where are these actual bits coming into and going out of the logic controller? And so, you know, to get all that information currently, you have to go to numerous different sources. Well, Signal Scout does the same job as what Google Maps does of bringing all of that information together, so that instead of going to various different places, you can just go to one spot and get all that information, which is going to help you get to the root cause of your troubles more quickly. So how does Signal Scout do that? It does that in 3 different ways. You can use LiveView, which is if you have a real-time trouble going on that you need to try to solve, or if you perhaps are doing like a cutover or something like that, you can take Signal Scout out to the field, plug it into a piece of equipment, and it's going to show you exactly what's going on with a piece of equipment in real time. So you can get, live information about exactly what's happening. Additionally, there's a mode that we call LogView, whereas this, could be that a maintainer gets a trouble call, and by the time they get to the field, the trouble's already, it's already gone because maybe they walked the train past the red signal or something like that. But you have to download a log and try to review that log to see what may have happened and get your root cause from there. So Signal Scout will work with your logs. It'll allow you to load your logs into Signal Scout and then go through them and see exactly what was happening at various times. And then the last mode is what we call training mode, which is essentially a simulator of your application logic. It allows you to set up initial conditions, input conditions, and then see the resulting output of what would happen, if that application logic was set up in that way. So this is going to be similar to Vital Sim or SATs, but there's not as much of the, we don't do all of the building of the visuals of the location as those do. So this is kind of a pared down version of what those softwares do. So what does Signal Scout support? So we have numerous different types of controllers out there. And currently Signal Scout supports the Electrologix family of products, which is your EC5s, your VLCs, your XP4 type equipment. It also supports VHLC, your older generation of Alstom products, as well as Microlock 2. For the VPI and the iVPI, we support LogView and training mode, and do not currently support the LiveView for VPI and iVPI. So with those basics out of the way, we'll get into a demonstration of how Signal Scout works. And we're going to start that demonstration actually by talking about a scenario that you might currently be familiar with, which is responding to a trouble call in the current method of how you might do that. So if I were a Signal maintainer and I got a trouble call, I'm going to go to the field. By the time I get to the field, let's just say that trouble has cleared, right? I can't see that trouble going on right now. So I'm going to need to download a log, and I'm going to need to look back in that log to try to identify what happened. So the first thing I need to do is I need to download that log. So I go in, I download that log, and I'm going to pull it up on my computer. Okay. That's usually just a straight text file like this, where you've got time-stamped events and then events occurring at those different time periods. So I'm going to scroll down to where that event happened, whatever time it may be, and I'm going to start looking through here. Okay. Now, if I've been doing this for a really long time and I know what all these things mean, I might be able to kind of, read the matrix and go through this kind of, comfortably and naturally. But if I'm a newer Signal maintainer, or this is a new territory for me, or I'm not familiar with the application logic or something like that, I'm going to need to bring in some extra additional tools to help me figure this stuff out. So once I've figured out, where should I get started? I'm going to need to identify, something that's gone wrong or something that's occurred. And then I'm going to need to see the equation behind that. So now I'm going to have to open up my program equation book. So I'm going to go over here and I'm going to pull up my equation book for this location. And I need to scroll through here and I need to look for the equation that I think is causing the problem, right? So I'm going to find that, and then I'm going to see that I have to identify the states of possibly numerous inputs to that equation. And so I start going through that process, and maybe I don't know what one of these equations stands for. Maybe I know what a TR is, maybe I know what a track relay is, and that's maybe an OS or something like that. But I don't know what some of this other nomenclature. So now maybe I have to open up some nomenclature, and I have to look in here and try to figure out what these various variables mean and what this particular bit could be referring to. Okay, so now I'm going through this process, I'm looking things up, I'm figuring out what the various states of things are, and eventually I'm going to get to some input equation that's coming into the box from an external source, and I need to know where that is coming in so that I can look that up on my prints about what to go troubleshoot. So now I need to open up my report file to identify, where a piece of information is coming in, so that I can now get to my prints and follow it further. So at this point, I've got 4 different documents open. I've got a whole bunch of different information kind of bombarding me. And it's really hard for somebody to take all this different information, first of all, to have access to it, and second of all, to know what to do with it and to be able to troubleshoot successfully. So that's the problem we're trying to solve, is this is just overwhelming. There's too much going on. It's not easy for anybody except those who have been doing this for a long time or have really been trained, pretty extensively on how to do that, on how to do this. So that's where Signal Scout comes in, okay? So we're going to get rid of all these various different windows, and we're going to take a look at how that same process might be tackled through Signal Scout. All right, so this is the screen that you will be introduced with when you first open up Signal Scout. Now, there's been some setup that I've done to make sure that I have some programs here that will help you with if you want to take Signal Scout for a spin, to make sure that we can get you guys set up with this. But in the scenario that we talked about, I had gone to the field and downloaded a log. So I'm just going to go ahead and find that log by going up here to this LogView portion and clicking this button that says Select Log. This is going to bring up this folder select. I'm just going to choose one of the logs that I have saved here for the CP Cardiff, and we're going to click Open. Now, Signal Scout's going to look at that log. It's going to look at the CRC and the checksum from the application logic that was installed at the time this log was downloaded. And it's going to match that and see if it can find a program that's associated with that. In this case, it did. And so we're going to open up this screen where we're going to be doing most of our work. And this is CP Cardiff. So let me take you on a quick tour of the screen here before we start looking at exactly what may have happened in one of these troubles. So here on the left-hand side of the screen, we have a list of all the variables that are part of this location, part of this equation. Here in the lower left-hand corner, we have some information. It's going to give some additional information about any variable that we might mouse over at any time. Along the lower part of the screen, we've got this blue scroll bar. That's going to allow us to control what time of the log we're looking at. So if I know the time that my error occurred, that my problem occurred, I can scroll towards that time using this this portion of the screen down here. And then at the top, we have some buttons that we'll go into in just a little bit, but I'm going to start by showing you, if you click on this little key icon right here, it's going to bring up this screen right here. And this is essentially our key for what are the different symbols that we're going to use while looking at Signal Scout. And most of these hopefully are familiar to those of us who are in the signal industry. The relay is drawn like most relays are drawn, back and front contacts, that sort of thing. But information like where power is present and where power is missing is used with colors. So green means power is present and red means power is missing. And we've got some other things going on here. And one of them, the important things, is this yellow background right here, which shows the state of something that has just changed. So usually, if we're looking for something happening, then obviously something has just changed. Something has just gone from true to false or false to true for that to happen. So this is going to kind of help us draw attention to what's going on there. So I won't keep this up the whole time, but just keep in mind that this is available to anyone who is using this and it isn't familiar with all the colors and symbols and that sort of thing that'll be being used. All right, so let's go back to our hypothetical scenario where we had some trouble going on. Okay, so we come here, and the only thing I need in order to get started to figure out what's going on with my particular trouble is a jumping off point, a starting point, right? So in this hypothetical scenario, we'll just say that a signal dropped from, or a signal wouldn't clear or dropped from green to red, one of the two. And we want to find out why that is. So in order to figure that out, what I need to do is be able to start at some place. And all I need to know to do that is, okay, if I have a signal drop from green to red, then I need to find where those signals leave the box, where they're sending out power to a signal. So if you click on this little up arrow right here, this is going to bring up your outputs. So all of the cards that are installed on this program, on this particular location, it's categorized them by card and by what is going on. So if I can go down here and try to find a lamp driver card, like this one right here, you can see that we have on IO slot number 3, we have a vital lamp driver. Then I can use this to try to identify which signals might be interesting to me. So for instance, say it was this 2WA signal right here. I could look that up and see that it's attached to a green bulb. If this is where I was interested in starting, I could click on this and you can see that it brings up the equation behind this bit right here. So I clicked on the 2WADGE and that brings up this signal lamp driver for output number 1 on this card, and then the equation behind it. So now I can scroll forward in time to the approximate time period where I have some trouble going on. And let's just say it's, let's see if I can find it going green. Okay, so there is when I have my signal being driven, my green signal being driven, so it's true. And now if I go forward in time, let's see if I can get it going false. Okay, so there we go. So now this signal went from green to false, so from green to not green. So if I go back in time once, we can see that at 22:41:59, so 11, almost 12, or sorry, 10, almost 11 o'clock at night on December 7th of 2020, this signal was green. And then if I move forward one time period, we can see that at a few minutes later, it dropped to not green. Now it might be red or we don't know, but this is just representing the green bulb. So now if I want to know why that happened, all I need to do is look through what Signal Scout has already put together for me. It's put together all of the states of the equations that lead to how this is being built. And I can just click on this one, this right here, because we can see that power starts here on the left side, and now it's not making it to the green bulb because this AHGR has gone false. So if I left click on that, we're going to get the same thing happening here, where we get the equation behind that bit, that AHGR showing up. So now I can do the same thing. I can just start here at the left and say, okay, why am I not getting power? Okay, because this GZR went down. Okay, let me click on that. And essentially, I just repeat that process until I get to a place where I can see that something occurred that is an input changing that caused all of this to trigger, right? So this is a multi-step process, starting from an input changing state to my signal going from green to no longer being green. And then once I get to an input, and this is the symbol that shows an input, it's telling me where that input is coming in. It's coming in on IO slot number 8, and it's vital input number 1. And now I can get out my prints and I can go to that input slot number 8, and I can look up what that is. You know, in this case, this happens to be an OS track circuit. This is just because this isn't a real trouble and just one that we found in a log. This is just a train taking a signal and going onto the OS, right? But this is the process that you would go through in order to find the root cause of your log. Now you can imagine if this were a more complicated issue, you know, there's a lot of steps and a lot of potential looking up of variable states that I would have had to go through that Signal Scout is doing for me. It's going through the trouble of finding all these states and what condition they're in at this particular time and displaying that to me, as well as showing me, you know, what has just changed. So that might be of interest to me. So now I can go in and I've got information that I can actually, you know, do something about. I can go and look at what type of equipment is running this this input to my device, and I can go make an adjustment there, or I can go replace, you know, something that's not working or that sort of thing. All right, so hopefully that made sense. And I do see there's a question here. And the question is, can you let me know what's the maximum time pulse duration for triggering? Okay, so it's a good question. So in a log view, which is what we're looking at right now, since the logs record everything that's going on, it could be recorded, you know, down to a fraction of a second. That's going to be shown here. So if, you know, you have something that's changing state from true to false in a fraction of a second, a tenth of a second, or something like that, as long as that's being recorded in the logs, which is a function that's external to Signal Scout, that's just a property of, the piece of equipment that you're using, Signal Scout will be able to identify it. Now, just to explain a little bit of how it works, you guys saw that when I clicked on this, this arrow to move the time either forward or backward, it didn't ask me how long do I want to move it or anything like that. Essentially what Signal Scout does is it takes a look at all the bits that are being shown on the screen right here. And when you click to move forward, it looks for the next state change of any of the bits being shown. And that's when it moves the time to. So in this case, it was, I think, 4 seconds. Oh, sorry, more than that. So from 4808 to 4832. So there's nothing that happened between, in the, whatever that is, 24 seconds between 4808 and 4802. There was nothing that happened between there, but at 4832, these two bit states went false. So as I move between them, it's just showing you the information that is useful for what you're displaying at the moment. I hope that makes sense. I hope my explanation of how that works made sense. Now, when we get to LiveView, because LiveView is not utilizing a log, it's actually connected to a piece of equipment and it's pulling information out of it in real time, you're not going to get the same responsiveness. So if I were connected to a really big Electrologix interlocking that has thousands of bits, it's not going to be able to show me that information in real time. It's going to be delayed by, depending on the size of the location, between 2 and 30 seconds, let's just say. So the bigger your location is, the less frequent the update of each bit is going to be. Now, for smaller locations, that's going to be very frequent. Could be every 2 seconds or something. For very big locations, it's going to be less frequent. But if there's ever anything that's happening so quickly that you can't see that in LiveView, just download a log, load it into LogView, and you should be able to see all those very minute, very small time sequence type things. So I hope that answers the question. All right. So the last thing I wanted to show you guys before we go and take a look at LiveView is another feature of Signal Scout, which is what we call the Nomenclature Assistant. So if you're able to see on your screens, hopefully it's not too small. When you look at the lower left-hand corner here, you can see that it's telling me some information right now about this 2W-GZR, and it's telling me it's the vital 2W signal request. And that's because that 2W-GZR is the last bit that I moused over, and it's giving me nomenclature information about it. Now, if I go and mouse over a different equation, like this 1WWNP, you can see that changed, and it's now telling me that the 1WWNP is the 1W track circuit electric clock normal switch position input. So Signal Scout helps you with nomenclature, which is one of the most difficult things for new signal people and anybody learning, new locations, new nomenclature, that sort of thing. It's going to help you identify and figure out what those different nomenclatures are. But this is something that has to be set up on a essentially case-by-case basis, because nomenclature differs across railroads and across, even down to subdivisions and lines and that sort of thing. This is something that has to be customized, but it's very, very useful when you do have it. And essentially, if you get it, set up for one line or one railroad, it can be generalized across multiple locations. So don't be intimidated and think that it's something that you have to, write out every single equation for every single location for it to be useful. It's more generalized than that, but that's kind of a topic for a different day, and we can go into more of that if people are interested. Okay, and then Mohammed just asked kind of what I touched on there, which is, does Signal Scout have a library for building that additional variable information, or do we have to set it up? It does have to be set up, but because I've set up some locations, multiple different railroads, we kind of have a base level. So if we can find something that is close to what yours is, we can give you that to start with and then build from there. So again, all railroads have uniqueness and things that are specific to them. But if it's close to, BNSF, or it's close to UP or something like that, then we can, start you with that and then customize from there. Hope that makes sense. All right. So any other questions before I move on from LogView onto LiveView about what you've seen or kind of the layout and the tour of the screen there so far? I guess I did forget to mention, although I referenced it a couple of times, the time that you're looking at in the log is up here at the top in the middle. So it says the current log time is, it's this, and it's telling you what time zone it was able to find from the log. Another nice feature that I'll show you real quick for logs is sometimes our logs aren't exactly right? They might drift, the time might drift a little bit. So you might go and download a log and the maintainer might see that, okay, the log says it's currently, or the equipment says it's currently 3:28, but the log says that it's currently 3:15. So I know that this log is actually off by 14 minutes. So what you can do is you can go in here on Signal Scout, and if you know that it's off by 14 minutes, you can change what time it knows. You can shift the log by that amount of time so that you don't have to constantly be saying, oh, should I subtract 13 minutes to this time to figure out what's going on? Do I need to add that? You can essentially shift it to be on the correct time if your device is not properly set up for the current time. And then it'll tell you the log has been shifted backwards by 14 minutes or whatever, whatever modification you make there. Okay, and then Mike Proctor is asking, can we input the nomenclature library, or does that have to come from your side? It does not have to come from my side. I have a manual and a document that explains exactly how you can make that yourself. So it's a fairly straightforward process. There's a little bit of kind of learning at the beginning, but once you've got that under your belt, it's definitely something that anybody can tackle themselves and not be reliant on me to generate. So happy to share with you that information and let you look it over so you can decide if that's something you'd want to tackle yourself. All right. All right, so I'm going to move. I don't see any other questions, so I'm going to move on to the live view. So all these modes are going to look very similar. The window is going to look very similar, and that is, of course, by design. We want to not have to learn how to do a bunch of different things for different products here. And another benefit to Signal Scout is that whether you're accessing a microlock or an Electrologix or a VHLC, the interface with Signal Scout is going to be similar. So where you might previously have had to access Electrologix through a web browser and microlock 2 through their their maintenance tool and VHLC through hyperterminal, instead you can access all of them the same way with Signal Scout. So I'm connected to a Electrologix right now, and so we're going to show you guys what LiveView looks like. Okay, so what I have to do in order to set up access to in this case, an Electrologix, is I have to have the correct program loaded, which this happens to be the correct program for what I'm connected to right here. And then I just have to have the right IP address set up. So as long as I could access this location through a web interface like I normally would to get access to an Electrologix, as long as you can do that, as long as your computer is set up to do that, and you have the IP set in there, you should be able to do the same thing through Signal Scout. So this is the IP address that I need to access that on. I'm just going to select it so that it's highlighted blue, and I'm going to click LiveView. It's going to come up with the same thing right here. And then here in the lower left-hand corner, you're going to get a message that it's connected and the status is refreshing approximately, in this case, every 1.9, 1.82 seconds. Okay, so if I open up, let's just take some of my outputs, and I can just open up some of my outputs and see what's going on with them. This is a very simple location. It's not a real location. It's just for my testing purposes. But it's getting the real-time information about what the status of these various inputs is. So if I take this input number 1 and I go over to my rack, and I'm going to flip a switch that moves this from getting a true signal to getting a false signal, you'll see it happen in real time. So let me step over there to do that real quick. So as you can see and maybe heard, I flipped the switch that changed that input number 1 from true to false. And then Signal Scout detected that change and it put that yellow highlighting behind it so that you can see, oh, hey, look, something just changed. In this case, it's the input number 1 as well as output number 1 because of the output equation being reliant on the input. So it's also giving you information here about, that this is an output and where it's going as an output. And then we saw earlier, how this is an input. So again, as mentioned earlier, if I were flipping that switch back and forth very quickly, you wouldn't see that happening because this is only refreshing every 1.8 or 2 seconds. But as long as we're not dealing with very fast stuff like that, we're not going to be missing state changes. Okay, so let's see. And we have a question on how is the interaction between 2 applications ensured? I'm not 100% sure I understand that question, but I'll answer it in a couple of different ways. So the first way that I'm thinking about is that there's usually 2 programs associated with, for instance, a control point, and that would be your non-vital and your vital side, right? So you're going to have 2 programs. You're going to have a non-vital program. You're going to have a vital program. What Signal Scout does is when we set up how your programs, how Signal Scout's going to see your application programs, we require that you put in the same folder the programs that go together. So if you have a non-vital program and a vital program that you want associated with each other for a particular location, you need to put those in the same folder. Signal Scout will match those together. The other question, or the other way I can see that this question could be interpreted is if I go and I select this location being at this IP address and I click LiveView, what happens if the application that I selected is not actually matching what's on the device? And if that's the question, then what Signal Scout does is it takes the CRCs and the checksums from the application that's on your computer, and it sees if they are the same as those that are on the device. And if they don't match, it tells you, it says, hey, you don't have a matching CRC and a matching checksum, therefore I'm not going to show you the real-time status because it would essentially be inaccurate, right? It would not be a true representation of what's going on. So hopefully between those 2 answers, I got to what the question was there. All right, so that is how LiveView works. And then I'll do one thing real quick. If, say, for instance, we had a situation where I'm out in the field and something's gone funny, or I just want to save the information about what's going on here for later. I can click this button right here with the little save disk icon. I'm going to click save state. I'm going to click on that. I'm going to give it this default name is fine, and I'm going to click save. Now, when we're going to go and take a look at training mode. And I will get back to the questions just a second after I continue this thought. So I'm going to go do the training mode for the same location. I'm going to select this and I'm going to click training. Same thing's going to pop up. And now, since we're in training mode, essentially what Signal Scout is doing is it is simulating how this program would function if it were running, but we don't require, we're not plugged into a piece of equipment and we don't need a log. So this is just allowing you to kind of freewheel and mess around with this however you like. Now, this obviously has very few inputs, but we could come up with a situation where, there's many locations out there that have hundreds and hundreds of inputs, if not thousands of inputs. And you wouldn't want to have to go through here and individually select these and set them to true and false, right? So instead, because I saved the states earlier from a location that I was plugged into, now I can go in here in training mode and click this button that says load state. I can find that one that I saved. I can double click on it and it'll load. And now you'll see that my inputs have been changed to what they were from the state that I saved them. So this allows you to very much more quickly get into a place of being able to train on something that has already happened in the field, or you could do this, you could load this from a log even. And that's going to allow you to, use this as a training device. You could say, hey, we had this situation in the field the other day. This is how the equipment was set up, and this is what was happening. What should we have done to, get us back into service, or what needed to be fixed, and that's going to allow you to load it up, go through the logic and see, how things were going. Or maybe you just want to, play around with how this stuff works, and you can, simulate dropping track circuits and recovering track circuits and seeing, did my signal drop and that sort of thing. Okay, so I'll get into a little bit more on training mode after I take a look at these questions here. Okay, so AB says, sorry, I missed the refresh rate on LiveView. For this particular location with very little going on, I had a refresh rate of 1.9 seconds for the electrologics. For VHLC, because of the method that we get the information out, it's almost instantaneous. Same thing for microlock 2. So it really depends on what type of equipment you're talking about and how big the location is. So for a large location of electrologics, it may be 30 seconds, just as an example. Okay, and then we have a question, can statuses be traced back to their source input, even if that is on another chassis or sent via Vital remote? Okay, that's a good question by Mike Weber. And this is a, so for that, in all instances, it's going to tell you where that's coming from. So let me go to a different location real quick that has a Vital remote. So I'm going to pull up this location, and we'll see that in this particular location, we have remotes. Okay, so over here, you can see here on port 3, we have networked remotes. And if I open one of these, it's telling you where it's coming in. It's coming in over port 3, remote number 1, input number 1. So if I'm looking at training mode, that's as far as I can go. If I'm looking at a log, that's as far as I can go. Now, if I were on an electrologics piece of equipment and I was on LiveView and I was using something that had remotes, if you have your other locations set up properly with their IP addresses set up properly, so say this location here was connected to the one next to it right here, as long as you have the IP addresses set up properly here in the settings, what it can do is when it detects you wanting to see what the status of this input is, because it's a remote, it can reach out to that next location. It can check the CRCs and the checksums of the location, open it up, and it can actually pull up that output bit that is the input bit on the location that you're referring to. So there's a lot going on there, and that was kind of complex, but the short answer is, in some circumstances, which is just electrologics and in LiveView, yes, it can help you jump through locations that have remotes and get to the input that you're interested in. So I hope that was the question you're looking, or the answer to your question there, Mike. Okay. And then I think the last thing, there's many more features, but we're not going to have time for all of them. And I do want to have time at the end for questions. The last feature I wanted to show was on training mode, was the ability to pause the execution, which I think is pretty useful. So I'm going to go through some things real quick to get us set up for that. And I'm going to show you guys what I'm talking about there. So, okay. Okay. So I have a crossing here that has a number of timers that run in a sequence of events before activating this crossing. Okay, so I'm going to go through, I'm going to start those timers. And if I start this guy right here, we'll see that this timer right here is running. And once the way that timers are shown for electrologics, because they're two different bits, there's one bit that goes true immediately, and there's one bit that will go true after the timer expires. So once it gets to 31 seconds, this bit is going to go true. And that's going to set off this timer going. So we're going to let it run through this one. And but what happens often with logic is one bit state changing results in a cascade of a number of other bit state changes, right? And so often that happens really quickly, and it's hard to follow exactly the sequence of events that happened. So once this gets close to 30 seconds, I'm going to hit this button up here in the upper right-hand corner. And this is for training mode again. That says pause, okay? So as we get closer here to 30 seconds. Okay, so I hit pause, and as we can see, the time run is just before this 30 seconds. We're at 28.3 seconds. So now, if I'm giving a class, if I'm doing some sort of training or something like that, I can talk to my class about what's about to happen without it just happening very quickly. And I could say that, hey, what do we expect to happen when this to_SAR_DLY_T goes true? And we can look at the logic and we can see that, oh, once this goes true here, our path for power is going to break, which means our TK2XR is going to go false, and that's going to result in this going false, and our XR is going to go false. So our crossing is going to activate, right? And then I'll bring up one more. And then because our crossing is going to activate, our bell is going to turn on, right? But if I let it go, if I hit play, we'd see all that happen very quickly because there's no timers associated with these things. But if I hit step, this button step right here, I'm going to click it once, and you can see that this timer moved forward just a little bit. It went from 28.3 to 28.8. If I hit step again, it's going to go forward by a second. If I hit step again, now we've completed the timer, and this timer bit has gone true, which you can see reflected here. But even though we have no power to this TK2XR, we can see there's no power coming here. It's still showing true. So this is allowing you to step essentially bit state change by bit state change through your logic. So if you want to talk about it and see each of these things happen in succession very slowly, you can kind of see that happen. So if I click step again, we'll see the TK2XR go false. And now we can see that the next thing that's going to happen is the XR is going to go false. So I'll hit step again. And then we can see that XR going false is going to start our bell ringing. So I hit step again. So this is really useful when you have, logic that you want to go through with people, that you want to see the results of it kind of step by step instead of it all just happening very quickly and simultaneously. So that is a neat feature that I wanted to make sure you're all aware of. Okay, so since we're about 15 minutes from the end here, I'm going to go back to the presentation, which we have just a few more slides on, and then I'm going to open up to any questions that anybody may have come up with. So feel free to type those into the chat, or you can ask them in just a moment. All right, so just to recap the use cases and benefits for the maintainer inspector level, frontline level, we're looking at faster and more accurate troubleshooting, uniform access to all of our different platforms, and hopefully that results in fewer repeat trouble calls, right? For frontline supervisors, this is going to improve your key performance indicators. It's going to hopefully spend less time for you reviewing logs, whether that's because now your inspectors and maintainers are doing more of the log review themselves, or because it's allowing you to do them more quickly and spend less time on them. And it's going to allow you to do and set up, custom training opportunities. So that obviously goes in with the trainers, allows you to more easily teach on relay logic and create your own scenarios, and teach on the same software that will be used out in the field. So instead of using generic software that is, for training that we often get, which is just like, here's how an XR works, or here's how an ASR works, you can actually train on your specific software. And then since we all do work for the operations group, this is going to result in faster returns to service and a reduced public impact, which means fewer phone calls and happier bosses. All right, so this is from an AREMA 2022 conference paper that we presented, a little bit of a case study that Signal Scout was used. So what is shown here is Signal Scout was implemented on this railroad in Q2 of 2020. So these two red numbers right here is before we started utilizing Signal Scout. And then this is the trend of preventable signal calls afterwards. So as you can see, a downward trend in preventable signal trouble calls. We can't necessarily say that this is only due to Signal Scout's use. Obviously this was accompanied with training and that sort of thing. But we do think, just from talking to the people and hearing their feedback, that was a big contributor. And then the other thing to note about this is, with this downward trend in repeatable trouble calls, there was actually a reduction in headcount at that time due to attrition to another property. as well as, with that headcount reduction, there was actually a reduction in the average years of service. So all this improvement was achieved, not only with fewer people, but also with a younger overall workforce. So we think this is, the data that really backs up the benefit of using Signal Scout. So how do we sell Signal Scout? Signal Scout is priced on a software as a service basis, essentially by licenses to use Signal Scout. Those licenses are assigned to a computer. You can transfer them computer to computer if you want. And essentially, there are different price breakpoints. So the more Signal Scout licenses that you purchase, the cheaper per license it's going to be. And then we also have this incentive right here that if you get to 20 users, then we will create the application, the Nomenclature Assistant files for you. So that is a pretty big value as far as time spent, because these things do take time to make, but we'll create those for you so that you can get the best use of Signal Scout for your 20+ users. And I think we're almost to the end. Oh, there's a couple more things. Okay, so in order to install Signal Scout, it's available on our website. The main thing for getting set up is collecting the necessary application program files. Once you've done that, we'll provide you with a product key and you can begin use. And for those, we didn't go, I should have gone over it earlier, but Signal Scout also for VHLC and Electrologix products will actually help you download logs. So if you want to use Signal Scout to help you download logs, and one of the big benefits is how it names logs for you. So that instead of getting a whole bunch of logs just called IXS_data log 1, 2, 3, 4, a million, it will actually help you name them so you know exactly when it was downloaded, where it was downloaded from, that sort of thing. And that can be used for free by anyone. There's no license required on that. All right, and so then for the last slide here before the questions, we do offer a 45-day free trial to anybody who's interested in giving Signal Scout a spin before purchasing. We'll take you through installation. We'll make sure that you're set up. There is walkthroughs on YouTube, as well as we're happy to do private, installation setups and that sort of thing. So contact information is provided there. It's semaphoresoftware.co. We didn't just forget the M. So semaphoresoftware.co is the email address and the website. And of course, we'll follow up and see who would like to start a trial of Signal Scout, and certainly look forward to getting you all set up and help you use Signal Scout. Hopefully it will be able to improve, what you're doing on a day-to-day basis, make you better at your job, make your folks better at your job, and help you out. So if there are no more questions, I will go ahead and end it, and I will thank you all for attending.